Here we go. We have a question, maximum sum path in two arrays. So you have given two sorted array of distinct integers, array 1 and array 2. Each array may have some element in common with other array. We need to find the maximum sum of the path from the beginning of the array to the end of any array. You can switch from one array to another array only at the common element. When we switch from one array to another, we need to consider the common element only once. So in this example, the maximum path we can have is, we will start from array 2, then we consider this element, then we consider 7. So 7 is common, so we make a switch, then 10 and 12. So the answer is this. So let's build the approach. We have array 1 and array 2, and we can start from any array and switch. So we have option to switch, or we can continue with the same array. So we have two paths. I will take two variables a and b, and I will start from backwards. You can start from starting, that's totally up to you. Here I am starting from backwards. So first I points to this value and j points to this value. So we need to find the bigger value. Bigger value is 12 and it is present in array 1. So I will add this element in array 1. Then I considered this element. Now I decrease my I. So then again we have to check whether array of I is greater or array of, or second array in the jth element is greater. So in this, our first element is greater, so we consider this element, then we decrease our I pointer. In this, second element is greater, so we consider b and we decrease our j pointer. Here we have both elements same, we have a common element, so either we can go to this path or we can go to this path. So this path we have in A and this path we have in B. We want the maximum path, so we have to take the maximum from A and B. Suppose this is the starting element, so we can continue in this path, we can switch. Here also we can switch or we can continue, so we have both options. So we take the maximum element. In this, maximum element is 22, so we consider 22 and we fill 22 in both values, because on this specific location we can switch to any array and we want the sub array to be maximum sum. But don't forget to include the current element, so we include the current element in both paths. So after considering this element, we need to decrease our I and j. In this case our j is greater, so I will add my j here, then decrease our j. In this, our I is greater, so add I here, then decrease your I. In this, I is greater, then decrease your I. Now at this location we cannot compare, so any element present in B, we will add the summation into B. If any element present in A, we will add it into A. In this, no element present in A, but we have an element here. So after finding A and B, we need to take the maximum path. So here we need to consider the maximum path, so we will return maximum between A and B, because we can start from any location, and I think its answer is this, B. So we consider 1 5, then 7, then 22. 22 is here. We switch from first array to another. So let's code this. First we have A and B, N and M, and I and J. I am starting from backwards. You can start from starting. That's totally up to you. So while this condition is valid, if array 1 element is greater, we need to add into A and decrease our I. If B is greater, we need to add into B and decrease our J. If both element is common, we need to consider maximum between A and B, and don't forget to include the current element also. Array 1 and array 2 is equal in this location. Fill this array into B also, decrease I and J. After this, if there is any element present in array A, so include into A. If any element present in to array B, so include into B, and at the end return the maximum between A and B. This code is given in the description box, and its time complexity is order n plus m, and its space complexity is constant. If you like this video, a click on the thumbs up button is highly appreciated, and subscribe to this channel. Thank you all for watching.